Occupational hygiene is the anticipation, recognition, evaluation, control and prevention of hazards from work that may result in injury, illness, or affect the well-being of workers. These hazards are typically divided into the categories biological, chemical, physical, ergonomic and psychosocial. The risk of a health effect from a given stressor is a function of the hazard multiplied by the exposure to the individual or group. For chemicals, the hazard can be understood by the dose-response profile, most often based on toxicological studies or models. Occupational hygienists work closely with toxicologists for understanding chemical hazards, physicists for physical hazards, and physicians and microbiologists for biological hazards. Environmental and occupational hygienists are considered experts in exposure science and exposure risk management. Depending on an individual's type of job, a hygienist will apply their exposure science expertise for the protection of workers, consumers and/or communities. The British Occupational Hygiene Society defines that occupational hygiene is about the prevention of ill health from work, through recognizing, evaluating and controlling the risks. The International Occupational Hygiene Association refers to occupational hygiene as the discipline of anticipating, recognizing, evaluating and controlling health hazards in the working environment with the objective of protecting worker health and well-being and safeguarding the community at large. The term occupational hygiene is synonymous with industrial hygiene. The term industrial hygiene traditionally stems from industries with construction, mining and manufacturing, and occupational hygiene refers to all types of industry such as those listed for industrial hygiene, as well as financial and support services industries, and refers to work, workplace, and place of work in general. Environmental hygiene addresses similar issues to occupational hygiene, but is likely to be about broad industry or broad issues affecting the local community, broader society, region or country. The profession of occupational hygiene uses strict and rigorous scientific methodology and often requires professional judgment based on experience and education in determining the potential for hazardous exposure risks in workplace and environmental studies. These aspects of occupational hygiene can often be referred to as the art of occupational hygiene and is used in a similar sense to the art of medicine. In fact, occupational hygiene is both an aspect of preventative medicine and in particular occupational medicine, in that its goal is to prevent industrial disease using the science of risk management, exposure assessment and industrial safety. Ultimately, professionals seek to implement safe systems, procedures and methods to be applied in the workplace or to the environment. The social role of occupational hygiene. Occupational hygienists have been involved historically with changing the perception of society about the nature and extent of hazards and preventing exposures in the workplace and communities. Many occupational hygienists work day to day with industrial situations that require control or improvement to the workplace situation. However, larger social issues affecting whole industries have occurred in the past, e.g., since 1900, asbestos exposures that have affected the lives of tens of thousands of people. Occupational hygienists have become more engaged in understanding and managing exposure risks to consumers from products with new regulations such as REACH. More recent issues affecting broader society are, for example, in 1976, Legionnaire's disease or legionellosis. More recently again in the 1990s radon, and in the 2000s the effects of mold from indoor air quality situations in the home and at work. In the later part of the 2000s, concern has been raised about the health effects of nanoparticles. Many of these issues have required the coordination over a number of years of a number of medical and paraprofessionals in detecting and then characterizing the nature of the issue, both in terms of the hazard and in terms of the risk to the workplace and ultimately to society. This has involved occupational hygienists in research, collection of data, and to develop suitable and satisfactory control methodologies. Workplace assessment methods. Although there are many aspects to occupational hygiene work, the most known and sought after is in determining or estimating potential or actual exposures to hazards. For many chemicals and physical hazards, occupational exposure limits have been derived using toxicological, epidemiological and medical data, allowing hygienists to reduce the risks of health effects by implementing the hierarchy of hazard controls. Several methods can be applied in assessing the workplace or environment for exposure to a known or suspected hazard. Occupational hygienists do not rely on the accuracy of the equipment or method used, but in knowing with certainty and precision the limits of the equipment or method being used and the error or variance given by using the particular equipment or method. Well-known methods for performing occupational exposure assessments can be found in A Strategy for Assessing and Managing Occupational Exposures, 3rd edition, edited by Joselito S. Ignacio and William H. Bullock. The main steps outlined for assessing and managing occupational exposures: basic characterization, exposure assessment, exposure controls, further information gathering, hazard communication, reassessment, management of change. Basic characterization, hazard identification and walk-through surveys. The first step in understanding health risks related to exposures requires the collection of basic characterization information from available sources. A traditional method applied by occupational hygienists to initially survey a workplace or environment is used to determine both the types and possible exposures from hazards. The walk-through survey can be targeted or limited to particular hazards such as silica dust or noise, to focus attention on control of all hazards to workers. A full walk-through survey is frequently used to provide information on establishing a framework for future investigations, prioritizing hazards, determining the requirements for measurement, and establishing some immediate control of potential exposures. The Health Hazard Evaluation Program from the National Institute for Occupational Safety and Health is an example of an industrial hygiene walk-through survey. Other sources of basic characterization information include worker interviews, observing exposure tasks, material safety data sheets, workforce scheduling, production data, equipment and maintenance schedules to identify potential exposure agents and people possibly exposed. The information that needs to be gathered from sources should apply to the specific type of work from which the hazards can come from. As mentioned previously, examples of these sources include interviews with people who have worked in the field of the hazard, history and analysis of past incidents, and official reports of work and the hazards encountered. Of these, the personnel interviews may be the most critical in identifying undocumented practices, events, releases, hazards and other relevant information. Once the information is gathered from a collection of sources, it is recommended for these to be digitally archived and to have a physical set of the same information in order for it to be more accessible. One innovative way to display the complex historical hazard information is with a historical hazards identification map, which distills the hazard information into an easy-to-use graphical format. Sampling survey equipment. An occupational hygienist may use one or a number of commercially available electronic measuring devices to measure noise, vibration, ionizing and non-ionizing radiation, dust, solvents, gases, etc. Each device is often specifically designed to measure a particular type of contaminant. Such devices are often subject to multiple interferences. Electronic devices need to be calibrated before and after use to ensure the accuracy of the measurements taken, and often require a system of certifying the precision of the instrument. Dust sampling. Nuisance dust is considered to be the total dust in air, including inhalable and respirable fractions. Various dust sampling methods exist that are internationally recognized. Inhalable dust is determined using the modern equivalent of the Institute of Occupational Medicine MRE 130 name monitor. Inhalable dust is considered to be dust of less than 100 micrometers aerodynamic equivalent diameter that enters through the nose and a mouth. See lungs. Respirable dust is sampled using a cyclone dust sampler designed to sample for a specific fraction of dust AED at a set flow rate. The respirable dust fraction is dust that enters the deep lung and is considered to be less than 10 micrometers AED. Nuisance inhalable and respirable dust fractions are all sampled using a constant volumetric pump for a specific sampling period. By knowing the mass of the sample collected and the volume of air sampled, a concentration for the fraction sampled can be given in milligrams per meter cubed. From such samples, the amount of inhalable or respirable dust can be determined and compared to the relevant occupational exposure limits. By use of inhalable, respirable, or other suitable sampler, these dust sampling methods can also use to determine metal exposure in the air. This requires collection of the sample on a methyl cellulose ester filter and acid digestion of the collection media in the laboratory, followed by measuring metal concentration through an atomic absorption spectrophotometry. Both the UK Health and Safety Laboratory and NIOSH Manual of Analytical Methods have specific methodologies for a broad range of metals in air found in industrial processing. A further method exists for the determination of asbestos, fiberglass, synthetic mineral fiber and ceramic mineral fiber dust in air. This is the membrane filter method and requires the collection of the dust on a graded filter for estimation of exposure by the counting of conforming fibers in 100 fields through a microscope. Results are quantified on the basis of number of fibers per milliliter of air. Many countries strictly regulate the methodology applied to the MFM. Chemical sampling. Two types of chemically absorbent tubes are used to sample for a wide range of chemical substances. Traditionally, a chemical absorbent tube filled with very fine absorbent silica or carbon, such as coconut charcoal, is used in a sampling line where air is drawn through the absorbent material for between 4 hours to 24 hours period. The hydrophilic material readily absorbs water-soluble chemical and the lipophilic material absorbs non-water-soluble materials. The absorbent material is then chemically or physically extracted and measurements performed using various gas chromatograph or mass spectrometry methods. These absorbent tube methods have the advantage of being usable for a wide range of potential contaminants. However, they are relatively expensive methods, are time-consuming and require significant expertise in sampling and chemical analysis. A frequent complaint of workers is in having to wear the sampling pump for several days of work to provide adequate data for the required statistical certainty determination of the exposure. In the last few decades, advances have been made in passive badge technology. These samplers can now be purchased to measure one chemical or a chemical type or a broad spectrum of chemicals. They are relatively easy to set up and use. However, considerable costs can still be incurred in analysis of the badge. They weigh 20 to 30 grams and workers do not complain about the presence. Unfortunately, badges may not exist for all types of workplace sampling that may be required, and the charcoal or silica method may sometimes have to be applied. For the sampling method, results are expressed in milligrams per cubic meter of parts per million and compared to the relevant occupational exposure limits. It is a critical part of the exposure determination that the method of sampling for the specific contaminant exposure is directly linked to the exposure standard used. Many countries regulate both the exposure standard, the method used to determine the exposure, and the methods to be used for chemical or other analysis of the samples collected. Exposure management and controls. The hierarchy of control defines the approach used to reduce exposure risks, protecting workers and communities. These methods include elimination, substitution, engineering controls, administrative controls, and personal protective equipment. Occupational hygienists, engineers, maintenance, management, and employees should all be consulted for selecting and designing the most effective and efficient controls based on the hierarchy of control. General activities. The occupational hygienist may be involved with the assessment and control of physical, chemical, biological, or environmental hazards in the workplace or community that could cause injury or disease. Physical hazards may include noise, temperature extremes, illumination extremes, ionizing and non-ionizing radiation, and ergonomics. Chemical hazards related to dangerous goods or hazardous substances are frequently investigated by occupational hygienists. Other related areas, including indoor air quality and safety, may also receive the attention of the occupational hygienist. Biological hazards may stem from the potential for Legionella exposure at work or the investigation of biological injury or effects at work, such as dermatitis, may be investigated. As part of the investigation process, the occupational hygienist may be called upon to communicate effectively regarding the nature of the hazard, the potential for risk, and the appropriate methods of control. Appropriate controls are selected from the hierarchy of control by elimination, substitution, engineering, administration, and personal protective equipment to control a hazard or eliminate the risk. Such controls may involve recommendations as simple as appropriate PPE such as a basic particulate dust mask to occasionally designing dust extraction ventilation systems. Workplaces are management systems to manage people and programs for the preservation of health and well-being of those who enter a workplace. Education. The basis of the technical knowledge of occupational hygiene is from competent training in the following areas of science and management: basic sciences, physics, occupational diseases, health hazards, working environments, program management principles, sampling, measurement and evaluation practices, hazard controls, environment. However, it is not read knowledge that identifies a competent occupational hygienist. There is an art to applying the technical principles in a manner that provides a reasonable solution for workplace and environmental issues. In effect, an experienced mentor, who has experience in occupational hygiene, is required to show a new occupational hygienist how to apply the learned scientific and management knowledge in the workplace and to the environment issue to satisfactorily resolve the problem. To be a professional occupational hygienist, experience in as wide a practice as possible is required to demonstrate knowledge in areas of occupational hygiene. This is difficult for specialists or those who practice in narrow subject areas, limiting experience to individual subject like asbestos remediation, confined spaces, indoor air quality, or lead abatement, or learning only through a textbook or review course can be a disadvantage when required to demonstrate competence in other areas of occupational hygiene. Information presented in Wikipedia can be considered to be only an outline of the requirements for professional occupational hygiene training. This is because the actual requirements in any country, state or region may vary due to educational resources available, industry demand or regulatory mandated requirements. During 2010, the Occupational Hygiene Training Association, through sponsorship provided by the IOHA, initiated a training scheme for those with an interest in, or those requiring training in occupational hygiene. These training modules can be downloaded and used freely. The available subject modules are aimed at the foundation and intermediate levels in occupational hygiene. Although the modules can be used freely without supervision, attendance at an accredited training course is encouraged. These training modules are available from olearning.com. Academic programs offering industrial hygiene bachelor's or master's degrees in United States may apply to the Accreditation Board for Engineering and Technology to have the program accredited. As of October 1, 2006, 27 institutions have accredited their industrial hygiene programs. Accreditation is not available for doctoral programs. In the U.S., the training of IH professionals is supported by National Institute for Occupational Safety and Health through their NIOSH education and research centers. Professional societies. The development of industrial hygiene societies originated in the United States, beginning with the first convening of members for the American Conference of Governmental Industrial Hygienists in 1938, and the formation of the American Industrial Hygiene Association in 1939. In the United Kingdom, the British Occupational Hygiene Society started in 1953. Through the years, professional occupational societies have formed in many different countries, leading to the formation of the International Occupational Hygiene Association in 1987, in order to promote and develop occupational hygiene worldwide through the member organizations. The IOHA has grown to 29 member organizations, representing over 20,000 occupational hygienists worldwide, with representation from countries present in every continent. Professional credentials. Australia. In 2005, the Australian Institute of Occupational Hygiene has accredited professional occupational hygienists through a certification scheme. Occupational hygienists in Australian certified through this scheme are entitled to use the phrase certified occupational hygienist as part of the qualifications. United States of America, practitioners who successfully meet specific education and work experience requirements, and pass a written examination administered by the American Board of Industrial Hygiene are authorized to use the term certified industrial hygienist to certified associate industrial hygienist. Both of these terms have been codified into law in many states in the United States to identify minimum qualifications of individuals having oversight over certain activities that may affect employee and general public health. After the initial certification, the CIH or CAIH maintains the certification by meeting ongoing requirements for ethical behavior, education, and professional activities. ABIH certification examinations are offered during a spring and fall testing window each year at more than 400 locations worldwide. The CIH designation is the most well-known and recognized industrial hygiene designation throughout the world. There are approximately 6,600 CIHs in the world, making ABIH the largest industrial hygiene certification firm. The CIH certification program was discontinued in 2006. Those who were certified as a CIH retain the certification through ongoing certification, maintenance. People who are currently certified by the ABIH can be found in a public roster. The ABIH is a recognized certification board by the International Occupational Hygiene Association. The CIH certification has been accredited internationally by the International Organization for Standardization, International Electrotechnical Commission. In the United States, the CIH has been accredited by the Council of Engineering and Scientific Specialty Boards. The Association of Professional Industrial Hygienists, Inc., was established in 1994 to offer credentialing to industrial hygienists who meet the education and experience requirements found in Tennessee Code, annotated, Title 62, Chapter 40. ABIH adopted the Tennessee Code as its basis for credentialing because it was the first legal definition in the United States of an industrial hygienist in terms of education and experience. The ABIH Registration Committee investigates and verifies, through electronic means of correspondence, both educational and experience accomplishments claimed by each applicant for registration. The committee determines the appropriate level of registration, registered industrial hygienist to registered professional industrial hygienist, and then authorizes the registration certificate to be issued. Canada. In Canada, a practitioner who successfully completes a written and an interview administered by the Canadian Registration Board of Occupational Hygienists can be recognized as a registered occupational hygienist to registered occupational hygiene technician. There is also designation to be recognized as a Canadian registered safety professional. United Kingdom. The Faculty of Occupational Hygiene, part of the British Occupational Hygiene Society, represents the interests of professional occupational hygienists. Membership of the Faculty of Occupational Hygiene is confined to BOHS members who hold a recognized professional qualification in occupational hygiene. There are 3 grades of faculty membership. Licentiate holders will have obtained the BOHS Certificate of Operational Competence in Occupational Hygiene and have at least 3 years practical experience in the field. Members are normally holders of the Diploma of Professional Competence in Occupational Hygiene and have at least 5 years experience at a senior level. Fellows are senior members of the profession who have made a distinct contribution to the advancement of occupational hygiene. All faculty members participate in a continuous professional development scheme designed to maintain a high level of current awareness and knowledge in occupational hygiene. Indian Society of Industrial Hygiene was formed in 1981 at Chennai, India. Subsequently, its secretariat was shifted to Kanpur. The society has registered about 400 members, about 90 of whom life members. The society publishes a newsletter, Industrial Hygiene Link. The current address of the Secretary of the Society is Shyam Singh Gautam, Secretary, Indian Society of Industrial Hygiene, 11, Shakti Nagar, Rama Devi, Kanpur 2,008,005. Mobile number 8,005,187,037. Examples of occupational hygiene: analysis of physical hazards such as noise that would lead to use of earplugs or earmuffs, planning procedures to protect against infectious disease exposure in the event of a flu pandemic, monitoring and testing the air for hazardous contaminants that can lead to potential worker illness and/or death. Examples of occupational hygiene careers: compliance officer on behalf of regulatory agency, professional working on behalf of company for the protection of the workforce, consultant working on behalf of companies, researcher performing laboratory or field occupational hygiene work.